So we're going to walk through a fairly simple time series forecast and then some data manipulation for visualization in Tableau. I tend to go pretty fast, especially when you put me in front of a crowd of people, so feel free to interrupt me at any point. So we have our data here. I've already run this module, so it takes a while. And we will be forecasting, this is employment data by county for California. This is just a sample of the data. Obviously, we got just Southern California here, and then just a few of the employment segments. This is just, like I said, just a sample of the data we download on a monthly basis. We usually utilize the download tool, which obviously comes in handy. It grabs all this data in one fell swoop every month for us. So the first step to forecast this data, most of the predictive tools require the data to be in a vertical format. This is obviously in horizontal. It's not all that friendly, but it's easy to manipulate. So we'll just transpose it on geography and type. We'll leave the data fields all checked, specifically to the dynamic and unknown fields. Make sure that's checked, so when the data is updated, it automatically grab the most recent month. And now you can see our data has been reshaped. Pretty straightforward. Just a side note, I just put a summarize tool here, just to look at all the different combinations of the geographies and types. Like I said, when we do all the geographies and all the types, it's, you're dealing with thousands of rows. Ideally, we write a batch macro for this and run through every iteration. Instead of actually doing it with this sample, I'm just going to use filter tools, and we're going to focus just on Orange County and total non-farm. But utilizing batch macros, you could run through every possible combination. So we'll filter this out, simple, Orange County, and we'll just look at total non-farm. And we have our data here. So just total non-farm. So now let's determine what model is the best fit model. You'll notice actually I already have the forecast tools up here. There are primarily two types of time series forecast tools that are offered. That's the exponential smoothing, the ETS, and the ARIMA, which is the autoregressive integrated moving average. So we're going to utilize those to determine which one's the best. And to do that, we're going to create a holdout sample first so we can actually test how they forecast versus actual data. So we'll come down here. And our holdout sample is just going to be the most recent year of data. To do that, what I've done here is first I've found the max of the historical data. So I've just got a summarize tool here, and I've got the date selected, and I just got a max. And I can tell that the data goes to April of 2015. So I'm going to take that max date, and I'm going to append it to just my raw data. So now I can see this is my raw data with this max date field in here repeated. And then I'm just going to use a filter tool here to filter out my holdout, my most recent year. So when date is less than or equal to, I use this date time add function a lot. It's pretty handy. It's less than or equal to the max date minus 12 months. You can see there's my holdout period from the holdout sample. So what I'm going to do next here is plug in the non-holdout data into the two tools, the ARIMA forecast tool and the ETS tool. For the sample, I'm just leaving all the customization at its defaults, except for the monthly. This is monthly frequency data, so I'm going to choose monthly. And we're forecasting 12 periods, so I'm going to put in 12 there. But as far as the model customization, I'm going to leave that alone. That's at least a day session in itself, going into all the settings here. But I definitely recommend doing research on them because they can significantly impact the outcome of your model. when we run these, they generate these reports here, which again have a lot of descriptive statistics that we won't necessarily go into in fancy charts. Primarily what we want to focus on is these sample error measures here, and both of these reports have these sample error measures. We want to minimize these. You can see that's the ARIMA report, and then the ETS report is a little bit different. But again, it has the same sample error measures here, which we want to minimize. So what we're going to do is compare these two models to see which one's better here. So we're going to union them. We're going to union their object output with the simple union tool. You can see we've got both models and their objects. And then we're just going to plug it into a TS compare tool, which is this one up here. We're going to plug in on the left side, we're going to plug in our models. And then on the right side, we're going to plug in our holdout sample. And there's very little configuration with this tool. So on the report, it generates this report. It shows us the actual data versus models. It shows us our accuracy measures, so there they are again. And then it provides a chart. And both of the lines are on here. It's just hard to see the ARIMA because they're actually both very similar as far as the results. They're both underestimating actual data. So you can see by this table, actually in every one of these stats, the ETS outperforms the ARIMA. You particularly want to focus on these two in most cases, the MAPE and the MACE. If you want to automate this process, which we've done in models in the past, so we don't have to open up this report and actually look at these tables. It actually outputs the data for us too, which comes in handy if I just transpose it a couple times. And with the formula tool, I can actually create just a simple table that goes through each of the stats and tells me which one is the best fit. So in all occasions here, the ETS is the best fit. So you can actually build this into your module and actually automate the whole process, so you don't have to ever pick the best fit model. Now there is some customization that probably should be done with each series of data, but you can automate some of it. So now that we know that the ETS is the preferred forecast model, we'll put another ETS tool here. Again, we will format it for monthly data. And we will also, we're actually going to put our start date in here too, because that helps us with the output. So I know my data starts in 1990, January. If the start date varies, especially if you're running a batch macro on this and each time series data is a bit different, don't worry, we'll get to that later. You can actually, when it outputs the data, just outputs it in ascending period, like 1, 2, 3, 4, 5, 6, 7, 8, and you can actually just use a formula tool plus your max historical date to just calculate the respective dates for each of the forecast months. So we will then plug in these TS forecast tool. This will output the data and it allows us to pick our confidence intervals as well. Again, 12 months, and we'll just leave these confidence intervals at their standard default values, which is 95%, which is 2 standard deviations and 1 standard deviation. And we get this report here, which provides a nice chart with the confidence intervals and then our data. And you can see what I'm talking about as far as when you don't have the start date, you don't put a start date in, this is going to be 1, 2, 3, 4, 5, and so on. So we have our data here, but we want to visualize this in, we want to create a visualization in Tableau, so we need the data. And that's what comes out of this output. So we have our data. And the goal here, we want to format it just like the historical data, so we can union it back to the historical data and create a dashboard in Tableau. But first, what this has done, it's dropped my measures. I don't have Orange County and total non-farm in here anymore. And if I'm running a batch macro on this with lots of counties and different job employment types. I need that data. So I'm simply just going to attach a sample tool back to my original data and just take the first record, because I'm looking for these two fields. That's all I want, is Orange County and total non-farm. And I'll disregard date and value. And I'll just append that to the data. And now I have that. So now we'll transpose it. Make it vertical, reshape it. So now I have, it's almost ready to union it back with the historical data, except I have to convert this period and subperiod into a date. Now there's probably several ways to do this. I just did it the way that worked best for me. As you discover with Alteryx, there's several ways to do about any task. But I wanted to get it in this format, month, day, date, year. So what I had to do first is convert the period and subperiod to string. Because I need, actually outputs it as a number, but I need it as a string because I need this to be 05 and 06, 07. So I can create a date that's in that format. So I convert it to a string. And then I just used a formula tool. So I pick subperiod here. So the length of the subperiod is 1. So if it's single digit, put a 0 in front of it. And then I'm just going to combine my new subperiod with an 01. They're all the first of the month. And then with my year, which is the period. And I get my subperiod with my zeros in front of it. And my string, my date string, which is now ready to be fed into the datetime tool, which is very handy. So I'm going to convert from a string field to a date field. And that's the format of my string, month, day. So now I get my date timeout, which is exactly what I'm looking for. Now I just have a select tool to get rid of subperiod and period. I don't need that data anymore, so I'm going to get rid of it. And then I'm going to join it back with my historical data. And you can see, if I look at this union tool, the only field I'm missing in my historical data, obviously, is the type of forecast, whether it's the first standard deviation, second standard deviation. And you can see that here. So I got a bunch of nulls where the data is historical. And we'll do something about that here in a little bit. And then, obviously, the type of forecast for data that's forecasted. So ideally, if you run a macro, it basically just spit out this data for every county and every employment type. And just stack it on top of each other, which is what we're going to bring into this next module. Or workflow. I guess they changed the name, right? It's workflow. I prefer module. Okay, so here is some data now for every county. Sorry, Southern California counties, and then about 5 different types of jobs. Just for reference, these are classified as high-paying jobs is what we're analyzing here. Financial activities, professional, scientific, and then management. So first, I just have a select tool in here because I'm renaming, I added a string issue in here, so I did reformat the string to include more characters. What I'm going to use here really quick is just a find and replace tool, because I don't like the names of these forecasts. We kind of have an internal naming convention that we use, like moderate, aggressive, semi-aggressive. So I'm just going to use a find and replace and just replace those names. So now I have all these say, my desired name. And then I'm also going to fill in these nulls with historical. So it's going to say historical. And I'm just going to do that using the simple formula tool. So if it's empty, put 01 historical. Let's leave it alone. Now, the next several steps, what I'm going to do is calculate the year-over-year growth in Alteryx instead of Tableau. I prefer to do as much as I can in Alteryx before I feed it to Tableau, just because depending on the complexities of your database, you can run into some issues with table calcs in Tableau, and I just prefer, much prefer to do it in Alteryx, especially if it doesn't need to be dynamic. If your users don't need to play with like parameter calculations, just do all the calculations you can prior to feeding it into Tableau. So what we're going to do, I'm going to cross-tab the data here, and you'll see in a minute why. So I have all my data here, my historical, let me scroll down, null, and then my historical ends and my forecasts start. So I need to calculate the year-over-year growth of each one of these, but I can't do that very well for this number when 12 months ago doesn't exist. So I'm just going to fill these nulls in with historical data using the multi-field tool, which is handy tool. So I want to focus on these columns of data, my scenarios. And basically all I'm saying here is if the current field is empty, then put the historical data in, else leave it alone. So you can see now, I have historical data in here. Now I can calculate my year-over-year growth. First, I'm just renaming these. So it puts an underscore, whenever you cross-tab, it puts an underscore in there, so I'm just renaming them back to my original names. And then I'm going to bring it back to its vertical form. And for visual purposes, I'm going to sort that just so we can see. So now I just want to add a column here that says year-over-year percentage growth. But obviously I can't just, and I'm going to do that using the multi-field tool, or not multi-field, the multi-role tool. But I got to group by, otherwise I'm going to run into some issues. For example, if I do this in Excel and just drag the column all the way down, I'm going to run into an issue right here where I switch scenarios or job type or geography. So what's handy, what I love about this tool is the group by. So I'm going to create my new field called value year over year. And I'm going to group by geo, type, and scenario. So it's just going to isolate each of those categories and just perform a simple calculation here, which is looking 12 rows back, performing the percentage growth. So now, percentage growth. And you can see where we run into issues if we didn't group by. You can see that here, because we want it to stop here. We don't want it to keep. We don't want that to keep going down because this, you don't want this to look 12 months back and calculate growth. Okay, and then this one here is just same thing, but it's just year-over-year growth, not percentage growth. And then what I'm doing here, I'm just appending the max historical date to the database. I use this using the summarize tool. I know my max date is here, April. So I'm going to append that to the database because I'm just going to, before I take it into Tableau again, I'm going to perform some simple calculations on just the historical data, and you'll see why in a minute. So I'm just going to filter out the forecast, look at the historical data, and this is just performing a max on the employment data. This was a request actually from a client. They wanted to know if aggregate employment numbers have returned to pre-recession levels. And I wanted to create a reference line in Tableau that was, that you can easily visualize this. And again, I want to do the calculation in Alteryx just because it was easier. So I'm going to join this max data to the original database. Now I have my data that is ready to be fed into Tableau. So these are my max values for that specific geotype. Okay. So now we're ready to look here, and it looks much better on my 30-inch monitor than it does on this. So you can see we have the aggregate numbers on top, aggregate job growth, and then the forecast. I'll zoom in here in a minute so you can actually see that. And then the year-over-year percentage growth on the bottom. Zoom in here. And you can see this max reference line, which we calculated in Alteryx. You can see that that's about 1.5 million. Orange County total non-farm growth is just about back to where it was pre-recession. Now, if we look at different segments, like financial activities, no, not even close. Professional scientific, up there. It is at the max. Management, not even close. So we can look at different, and actually this calculation is in Tableau. It's actually just summing up these three for a proxy for high-paying jobs. So you can see as a proxy for high-paying jobs, we're almost back in Orange County. Look at Inland Empire. San Diego. Ooh, they're doing well. And then a simple table as well. Again, this does not look good on the screen. Which just has some percentages, year-over-year percentages for April for every geo and every type, and then a long-term benchmark so you can compare. And we can select years, we can select months. If I want to see March in there too, or just May, which I don't have. 2016, yeah. Okay. Any questions?
Yes. The reference line, is it possible to make it dynamic so that it picks the average of different point in time or different period?
Yes, you could do that in Tableau. If it needs to be dynamic, yeah, you could do just about anything in Tableau to, well, not data wrangling wise, but as far as calculating, making dynamic reference lines, you could do it. But if it doesn't need to be dynamic, I prefer to do it before it's actually fed.
So if you would need to do it dynamic, do you need to feed another data table into Tableau in order to do this?
No, you wouldn't need to feed anything into Tableau. Tableau can calculate it based on what data is being viewed in the window or the overall data. You can pretty much calculate any sort of dynamic reference line you'd like in Tableau. Yes.
And you will share all of this with us?
What's that?
You will share the data and what you did and the Tableau piece? So
We'll see about that.
I mean, you can ask for money.
There actually is there's a good sample in the samples here that I recommend everyone take a look at. Where is it? Predictive, and then it is TS plot and time series forecast sample. These are very powerful. Kind of actually taught me the basics first before went on and did a little bit more research on each individual tool, but it kind of gives you the process and the flow of finding the best fit model. Anyone else? Yes.
I got a question. I'm a little surprised that you didn't do more visualization before you started doing the model fitting. Is that just something that you did offline?
Yeah, this is just for time sake too. Yeah, obviously I do a little bit more with the TS plots. I didn't get into TS plots and a little bit more in the descriptive statistics, but yeah, I mean that's a week-long session in itself if you go into all the stats. Is that it?
Do you model outside of Alteryx kind of what R or other stats program then to kind of figure out the parameters and then feed it back into Alteryx? Or how do you consider using Alteryx for your modeling or other software?
I prefer Alteryx. I've used eViews, eViews and SPSS, but I definitely prefer Alteryx. SPSS, I mean, it has some more options unless you're fluent with R. I mean, you can really dive in with Alteryx, but it's got most of the stuff you need, most of the basics.
Any tips in cutting down the run time?
Cutting it down,
Yeah, cutting down the run time when you run.
you got to try to be as efficient as possible with your tools. But when you're using the time series tools and the predictive tools, if you're feeding lots of data into it, it's going to take a while, no matter what. I mean, you can ask the solutions engineer. They take a while. We have models like if I run that batch macro with every employment category and every county, yeah, we'll be here a while. Can I get off the stage now?